All right, today we're going to start lesson 49 on trapezoids. And you know the definition of a trapezoid because we talked about it briefly when we were doing the area formulas. So this is the first part of section 6.6 on trapezoids. The second part talks about kites. We're going to learn how to use the properties of trapezoids today, and there's 3 theorems that we'll be discussing. It says that a trapezoid is a quadrilateral with exactly one pair of parallel sides. Now those are not marked in this picture, but you need to mark the bases as the parallel sides. These are the parallel sides, so make sure you mark yours. All right, if you continue, you'll see the definition for the parallel sides are called the bases. So if I look at the ones that are parallel, the top and the bottom in this case, those are going to be called the bases. And we've talked about this briefly before. Next, the non-parallel sides, and if these two are parallel, then these have to be the ones we would refer to as non-parallel. They're called the legs of the trapezoid. Now, we haven't used that vocabulary word before. The parallel sides are called the bases, and the ones that are not parallel are called the legs. It says, what must be true about the angles that share a leg in any trapezoid? Now, what I mean by share a leg, I mean they're on either end of the leg. So here I have angle 1, I have angle 3. Here I have angle 2, I have angle 4. They are sharing this leg as one of their sides. So I'm asking you, what must be true about the angles that share a leg in any type of trapezoid? And what has to be true is remember that your bases are parallel. Your bases are parallel. So that means that this is acting as a transversal. This is acting as a transversal here. Parallel, parallel, transversal. So these two angles would be called same side interior. And you should remember that same side interior angles are going to be supplementary. They're supplementary because they are same side interior. So that means if angle 1, let's say, was 100 degrees, then that would mean angle 3 would have to be 80 degrees. The angles on either end of a leg are supplementary. All right, let's go on talking about angles that share a leg or supplementary. So we're just going to put some different numbers to this. It says if angle 1 measures 105, so if angle 1 is measuring 105, how much would that mean angle 3 has to be? This angle is now 105. How much would angle 3 have to be? And so we think about it. Remember, they're supplementary. So angle 3 would be 180 minus 105, which would be 75. Now, in a trapezoid, opposite angles are not congruent. A trapezoid is totally different than a parallelogram, so don't be thinking that these angles are opposite and congruent. I think it's pretty obvious that 1 and 4 are not going to be congruent to each other. So I would have to tell you that the measure of angle 4 is 60. And then if I'm asking you what's the measure of angle 2, so I've just told you that angle 4 over here is 60. And I'm asking you to find the measure of angle 2. Again, these angles are supplementary. So to find 2, we would say 180 minus 60 would be 120. This is true for all types of trapezoids. Angles that share a leg are going to be supplementary. All right, so let's look at this situation. It says two angles that share a base are called base angles. Two angles that share a base are called base angles. So I have two pair of base angles in this trapezoid. Don't know if you can identify them or not, but if you look closer here, we have A and B are on either end of this base, and C and D are on the end of the lower base. So our two pairs of base angles, and let's notice to what I'm calling them, base angles. They're not across from each other at all. They are sharing the same base. Now this one says isosceles trapezoid, and if you think about what the word isosceles meant in triangle, at least two of the sides were congruent. For an isosceles trapezoid, the definition is if the legs, which are the non-parallel sides of a trapezoid, are congruent, then the trapezoid is classified as an isosceles. So I'm looking at my trapezoid. These are my bases, marked with the parallel markings. These have to be my legs. My legs are congruent, so this would be an isosceles trapezoid. So you can have just a plain trapezoid, or you can have an isosceles where the non-parallel sides or the legs are congruent. Now, on the following slides, we're going to talk about two theorems that hold true only for isosceles trapezoids, and then one theorem that's true for all trapezoids. So theorem 619, and you should have already written this in your notes, says if a quadrilateral or a four-sided shape is an isosceles trapezoid, then base angles are congruent. So remember where we have base angles over here. We have base angles at A and at B. And we have base angles here at A and at B. And then we have base angles at D and C. So the ones that would be congruent are the ones that share the same base. So A would be congruent to B because they're sharing the same base. C and D are sharing the same base, so they would be congruent. And I'm saying, think about the arrow pointing to the other congruent base angle. So right here I have angle A, and I'm kind of thinking about this arrow pointing me to the other angle that it would be congruent to. Same thing down here, base angle D. There's that arrow pointing over to angle C. If they share this base, or they along this parallel side here, they are going to be congruent. And this is just a reminder, base angles are always congruent in an isosceles trapezoid, but leg angles are always supplementary in any type of trapezoid. Now, if I'm looking at this problem, I think the first angle that I would be able to find would be this angle right here at 1. So I have, find the measure of the missing angles, and I'm asking you, what is the measure of angle 1? Well, here's that arrow or that indicator that this is a base. Base angles are congruent. Since 1 and angle measuring 74 degrees are base angles in an isosceles trapezoid, they have to be congruent. So the measure of angle 1 would be 74 degrees. So this would be 74. Now I need to find the measure of this angle 2 up here. What will that be? Well, now y'all, they are not sharing a base. They are not base angles. There's no parallel marking here. So these are the leg angles. And remember, we said that leg angles are always supplementary in any type of trapezoid. So for angle 2, we would think about angle 2 and angle 1 share a leg, so they are supplementary. And you might be saying, where's the marking? But up here I had talked about an isosceles trapezoid, so you can go ahead and put your marking here because I intended for that to be an isosceles trapezoid. All right, let's keep going. So the measure of angle 2 would have to be 106 since it's the supplement of 74. All right, now this one is marked nicely. This is an isosceles trapezoid. I'm given one angle and I'm asked to find the other two. Now y'all, there's only two relationships in an isosceles trapezoid. Base angles are congruent and leg angles are supplementary. Y'all, those are the relationships we've been working with all year pretty much. Angles are congruent or angles are supplementary. So for the first situation, I would try to find angle 2 first. It says find the measure of the missing angles, and I think I would find 2 first because angle 2 and 110 share a leg. This is the leg. So that means that they are supplementary. So the supplement of 110 would have to be 70 degrees. Now I know that this angle is 70 and these are base angles. And what do we know about base angles? Base angles in an isosceles triangle are congruent. So if I go and try to find the measure of angle 1, I know they're base angles of an isosceles, so they're congruent, so angle 1 has to also be 70. It says using the properties of the isosceles trapezoid. So they are giving me that the measure of angle S is 50. And they are asking me to find the measure of the remaining angles. Here's that arrow pointing to R. So R would have to be 50. And then I'm moving on down and I'm thinking about how does P relate to S. They are sharing a leg. So that would be 180 minus 50, which would be 130. And then when I get down here to angle Q, there's that arrow pointing. So if P was 130, I would know that Q would have to be 130 also. The point I am trying to make with isosceles trapezoids is that opposite angles are not congruent. It's angles that are sharing a base that are congruent. And then angles that share a leg are supplementary. Theorem 620 says this. If a quadrilateral is an isosceles trapezoid, then its diagonals are congruent. This is a trapezoid. I have one pair of parallel bases and I have a pair of congruent legs. So this is definitely an isosceles trapezoid. So that would mean, since I have an isosceles trapezoid, that the diagonals, you know what the diagonals are, they're going from A to C, B to D have to be congruent. So let's look at an example. Find the length of the diagonal in the following isosceles trapezoid. It says that we need to find X to Z. So we're trying to find the distance across here, X to Z. Okay. What else do we know? We know that W to Y is 12. W to Y is the other diagonal that goes across here. So that means diagonals are congruent in an isosceles trapezoid. And so this would be 12. Now there aren't markings here in this picture, but please notice that in the heading up here, I tell you that this is an isosceles trapezoid. So make sure they are telling you with words, telling you with marks, or they might, tell you with numbers that these two sides are congruent. Make sure you're working with an isosceles trapezoid. I'm going to stop this video before I continue on with the other part.